All right, so I've got 2:45. I'm going to go ahead and get started here. Unfortunately, I've seen a lot of speakers have two screens and they can see chat. I'll probably go full screen here so I can get a little better of the view. So, but I'll periodically check chat to see if there's any questions. Uh, Probably best to put your questions in there, and maybe at the end, I think I'll have like maybe 5 minutes left over. So, all right. So, welcome to the talk, Home Security from Scratch. This is a project that I've been wanting to do for quite some time. Bit the bullet because of all the COVID stuff. Bought the hardware, put it together, and made it. So this is indeed my house, which we'll be talking through. So who am I? Heath Murphy. I'm definitely a cat guy. This is not my cat, by the way. I have a Siamese cat, but um, I am a Director of Architecture Engineering at HMB. So we have a local presence down at Louisville. And because I'm a consultant, I still get to code. Big bonus. I am part Hungarian and pretty much all Irish, which of course makes me a hungry Irishman. Har, 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 har. And being Irish, I like beer, right? And pumpkin ales, while they're in season, is the best. Also, the dankest Imperial double IPA I can get my hands on. And the good news is pumpkin season is here. I know it's August. Some of you don't do pumpkin beers, but I love it. Yeah, as early as early August is when they start coming out, and I've got I think about 150 bottles I bought so far. I just hoard it, and then I have it all winter long to drink. And yes, I very much look like these guys, and I wish I could hear everyone laugh. Maybe I can see you laugh virtually. Okay, so the agenda. Here's what we've got. We're going to go through, actually jump right to the end. I've got a video tour that I'm going to show you of the end result, because what better place to start than at the end? And then we'll come back and so being an architect, having an architecture background, we'll do an architectural overview. Probably spend too much time on that just because I like architecture. Jump into the hardware things. I want to spend a lot of time on the hardware because I assume most of you guys are software guys. So make sure you understand the hardware that went into this. And then of course we'll cover the software things. With all of these slides, I've added just pictures here to show you kind of the story as I built this. Some of them make sense to the slide, some of them don't. This one in particular is my control panel. So you can see all the test wires I've got dangling off of it. This is on my bench, working through some of the bugs to get it all coded up before I got it mounted on my wall. So let's start with the end result. This is it. This is my entryway, and there is my control panel on the wall. So I've got a short video here. And I apologize with the video. What I learned is I cannot actually share my audio. So I'm going to play the audio through my speakers into the mic back to you guys, and I hope it works well. I'll keep chat up, so if it doesn't work, just let me know that you can't hear, and I'll turn up the volume. Okay, here we go. Everyone, I'm Heath, and I'm going to take you on a virtual tour of my house. It's going to accompany the talk here, so I've got a lot of things I'm going to show you. Some of them are going to be simulated, so this is going to be just to prove that it's not all smoke and mirrors and that what I actually have works and I am using it. So welcome to my tour. Okay, first thing I'm going to show you is down in the basement. So I do apologize, it's a little dirty down here, not terrible. And here is the rat's nest. It's a little bit better. I do need to do some more cleaning up to make it look a little better. It's on my list of to-dos, but this is it. You can see right there, that is the Raspberry Pi, kind of wired up down inside there. A lot of wires. I'll be sure to cover all the details on how it's wired and how things are working. You see a couple things down here at the bottom. One is a relay, and the other is a chip I'm using to monitor the smoke alarms. So again, I'll go over both of those. And on either side of the box, I've got terminals. And terminals obviously carry voltage. So I got a 3.1 or 3.2 volt terminal over here, and then my 12 volt there. It's actually 3.3 volts. See, all this big bundle of wires there, I cleaned it up a little bit. It was a rat's mess when I first moved in here. Those go all over the house. So there are a ton of wires there. And then my makeshift wire here, you can see my little orange plug. Funny story about this, which I'll cover in the talk, goes up across my beam here in the basement, way over there. I like the blue tape. And let's walk over here and show you what we got going on over here. There is where I've hooked up the Raspberry Pi for upstairs for my control panel. I've had to run the power all the way over here, and again, I'll tell you a little bit about that story when we get to that area of the talk here. But that wire there goes upstairs, directly above us, essentially, is where that Raspberry Pi is wired up. So, one more thing down here in the basement to show you. There is, actually this one right here, is one of the smoke detectors that I've got wired up. And you can see it's right where it should be, down in the basement, right beside the HVAC. And I've got over here a power cord for camera outside. Okay, let's go upstairs. Just to show you what a sensor looks like. Okay, so that is a magnetic sensor. So these are on all the windows in the entire house. And here's our living room. And you can see up there, I've got a camera. And that's my fiance, don't mind her. Right here, you can barely see it. I've got a better picture here, but there's a little, it looks like a little circle. That is the magnetic sensor on the door. And outside here, I've got my camera there. That was a speaker. You can see, speaker, not a speaker. I didn't get a speaker. And so here, smoke and mirrors. Let's open a door. So there's the door, there's my garage. And there you go. See the red there? Door, 1 of 3 opened. So we clicked into it, and garage door opened at 5:17 p.m. So we go ahead and close it. And there you go. Automatic. Didn't have to touch anything, didn't have to refresh. This is all a website in Vue.js. And of course, I can arm the system. And that arms the entire system. And right now, apparently, there's my motion sensor. So that is why we're getting some warning there. So lastly, what I wanted to show you is the app. So kind of, hopefully you can see on the screen here, I've got them up kind of side by side. This is what I call the cloud dashboard app. Fancy name. Vue.js application. I've got it here. So let me refresh to get that up to date. You can see there it went. So now we've got both of them saying armed. Okay. Now I'm logged in, so I've got authentication through my username and password. So I can unarm, and there you go. You see how it just magically updated? And on the application here, I can go down and see, so we opened up the garage door. So let's look for the garage door here. And there's this garage door, 5:17 p.m. You see the audit history. That's when it was opened, which matches what was out. So that is it. I've proved that it works. So now let me talk about how I did it and how all the things work together as part of the topic. Thank you. All right. Hopefully that was informative, and you can hear me a little bit better now. So let's jump into how I did it. So let me make this full screen here. So architectural overview. So let's talk about all the big pieces that kind of made this up and how they're all working together. So true story. When I first built this, I had a bunch of wires dangling everywhere. I'll go through, I have pictures to show you kind of the wires down in the basement, but I had one wire that actually went to a camera right on my front door. So it sits right above my front door and kind of looks out so you can see, people coming to your front door. The wire was hot. I was getting a spark out of it, and down in the basement, nothing was connected up. So I couldn't figure out why this stupid wire was hot and where it was getting 12 volts from. Did some research, and by research, climbed up in my attic and found, so here's the 12-volt power supply. For some reason, when they installed this, they installed a whole outlet up inside the basement or in the attic, and then just ran the wire down through. So odd things you run into, but that's what I found. Okay, so I call this the CIO diagram. CIOs don't have a whole lot of time. You're in a room, you're an architect, you need to quickly get the point across. So we'll start really high, and then I promise you we'll get into the details. So starting at the very bottom, this is our sensor monitor. Again, it's a name I called it. Raspberry Pi, it's in my basement. It's what you guys saw on that gray plastic enclosure. Its job in life is to sit there and sense all of our sensors. So all the windows, doors, smoke detectors, it runs and periodically checks the status of those and reports up to our control panel, aptly named because that's what drives the control panel. Again, also Raspberry Pi, 4 GB model. It also has a SQLite database. There's no database down here with the sensor monitor, but I have a SQLite database with the control panel. Then lastly, this wouldn't be an enterprise system without having some kind of cloud dashboard in it. So of course I push everything to cloud. It's Azure. I've got an instance running there, full version of SQL Server, push the data there, and then ultimately my phone connects to the cloud dashboard. Big scary diagram. A lot going on here, but let me explain it. We'll go through it step by step and hopefully it all makes sense. Bring up my good laser pointer here. So start down with the sensor monitor. It's running Ubuntu 19.10 on top of the Raspberry Pi 4. I've got all Raspberry Pis come with a GPIO controller, right? I mean, that's built into it. That's the reason we like them, we buy them. So it's part of the hardware. We're going to walk through the blue lines and then come back down the red. So our blue lines are basically our inputs, all of our sensors. So we're monitoring this. So we've got a process. Again, this is .NET Core running on Ubuntu. I've got a process that's self-hosted that runs every 2 seconds, or it runs and then wakes up every 2 seconds, reaches out to the GPIO controller and says, give me the status for all these. Are you open? Are you closed? Are you detecting smokes? Are you sirening? What are you doing? So it wakes up, reads the value of all those, and then uses a SignalR connection to push those statuses up to our control panel. One thing you'll notice with this architecture, and one of the big takeaways that I'll go through at the end, is SignalR is amazing. It's the reason this is so lightweight, the reason it's so fast, and you don't have to use this with a Raspberry Pi hardware. SignalR is production ready for your web application today, and you should be using it. It's amazing. So I've got a SignalR connection. Up in my control panel, I've got hubs. So if you never worked with SignalR before, think of a hub as kind of like an ASP.NET controller, similar to that. It's your endpoint. So clients connect to that, and you can also push messages through that. So at the control panel, I've got two hubs. I've got one for our sensor monitor to connect to, and then I also have one over here for our Vue.js application in the control panel to connect to. So I push the statuses up. Those statuses get written into a SQLite database, and then they're stored there. Got two processes here in this control panel. Again, same thing. This is running, you saw it mounted to the wall, Raspberry Pi 4, Ubuntu 19.10. I've got two processes that wake up. System status will go through first, wakes up every 30 seconds and checks systems. Now, what the heck is a system? I don't know, I just made up the term, but it's basically, do I have Wi-Fi? Do I have connectivity to the cloud dashboard? Believe it or not, I treat the sensor monitor itself as a dashboard or as a system. So if I haven't received statuses in the last, I don't know, 20 minutes, then there's probably something wrong with the sensor monitor. I need to check that out. So I flag it as a red here. So that runs every 30 seconds, stores them, and then pushes them out to the control panel. Also running every 2 seconds is a cloud dashboard sync. So 2 seconds seems like a lot, but this runs and just looks for changes. So if it wakes up and a window hasn't opened or a door hasn't opened, it goes back to sleep and does nothing. But say something does change, I want to push that up to Azure, store it up in here, and then eventually have it onto my phone. So a bit aggressive with the timing, but it's just me, my house, and I wanted to, 2 seconds here, 2 seconds here, within 5 seconds, let's say, maybe even 6 seconds, I know that a window's open or door's open or, God forbid, the smoke alarms are going off. So that's the reason for this. Push the statuses through SignalR. I've got a connection to the cloud dashboard, again, running in Azure. You see this little lock symbol? Basically, I don't want users connecting to my house and turning on my siren. That would be the worst thing ever. So things that are outside of my network, this line here, right? The control panel's physically connected to my wall, as is the sensor monitor down in my basement. So these are within my network. This is outside my network, so I've got them locked down. I'm using identity, Microsoft Identity services with JWT tokens. So get a token, store it, and then pass that token along with requests. Statuses go up, they get saved to SQL Server, they're there. And then I've got a process here that runs every 2 seconds for alerts. This is checking, is my smoke alarm going off? Well, I want to know about that pretty much immediately. I don't want, I want you to push me a notification out to my device. Or is the system armed and a door opened up? Okay, someone's breaking into my house. So in those cases, so the job of this is to basically wake up, determine if there's some kind of alarm condition, and then again, send that out to the mobile app. Okay, lastly, so that's all the blue. So red, there's a couple things I can do from the apps. One is arm the system. I can arm it from both the cloud application, my mobile phone app, and also the control panel. And both of those, come down. So ARM comes down through all the layers of SignalR. This is, if you've not worked with SignalR before, the WebSockets, it's a push, right? So that's the cool thing about this. I can push both directions. So from the server, from Azure, I can push to my house to tell it to arm the system, which would arm the system. And similarly with turning on the siren, I didn't want this to be automated because I'll be honest, that siren is loud. And I've got some funny stories to go along with that, but suffice it to say, it'll really hurt your ears. So I don't have it automatically going off. If I get a notification and choose to turn it on, it'll flow all the way down and then ultimately get down to our GPI controller to push and turn on the siren. A lot going on there. Hopefully it kind of all makes sense. I'm going to kind of go side screen here so I can get and see if you have any questions as I go through this. Hopefully you still get a good view of the slides. Okay, so Heath, why this architecture? Well, so I'm a consultant and I'm an architect, so therefore it's my job in life to maximize complexity whenever possible. No, that's not really the case. So some of the goals that I had in mind here is needed to operate without the cloud service. So as we all know, internet connections are flaky. Mine's pretty good actually, but they go down. I still need an alarm system to work in my house. I need to be able to arm it and track things. So the system's built for eventual consistency. That SQLite database will track basically all the states. So the windows opening and closing. Eventually, at some point in time, I'll get a SignalR connection to Azure and then push those statuses up and then clean out that SQLite database. So that was a goal and part of the reason for some of the complexity with the design here. SignalR is just freaking fast, lightweight, pushing events around as they come, as they pop up is awesome. One goal was no inbound connections. I didn't want people hacking my system and turning on my siren without me knowing. So all connections to SignalR are outbound. And then of course, because of WebSocket, I can push back to my house. Then separation of concerns, of course, smaller deployments. Okay, back to this. You guys saw this. This was a speaker. You saw it in the video. I don't use the speakers. The prior owner had it up there. I wanted a camera looking at my back patio, that door that I walked out. So this thing seemed like a good place. And actually the speaker wire that he installed here, really heavy gauge. So track that back down into my basement where you saw. There's 4 wires here because he had it connected to a rheostat so he could control volume. I just needed 2. So installed a makeshift plug here, plugged it in, 12 volts, good to go. And don't mind my cutting job here. It was a little off, but it's okay. It works. No one sees it. It's in the basement. All right, the hardware things. I'm going to spend hopefully quite a bit of time on this to go through how everything's wired up. Hopefully this is what you guys came to see. It was exciting to me. I have kind of a hardware background. If you have no hardware background at all, hopefully it all makes sense here when I get through it, but not scared at all, no falling up and rolling underground, I promise. Okay, let's start with what ADT left behind. So this is not exactly what it looked like before, but this is, it was way worse. It was just a mess of wires everywhere. When I bought the home, I went in there and just tons and tons of wires. I put them up here and just stuck them there. And then eventually when this COVID thing hit, decided, okay, now it's time to do this project. Let's go out and tackle it. So, so I started with a ton of wires. I knew I had sensors. I have a motion detector here that was left. This camera was left. Sorry, not the camera, but this location. ADT had left a camera there, or the prior owner, from like 2011. It was crap camera. I didn't want it. So I replaced it with this nice 1080p Wi-Fi enabled camera and just used the wiring, which of course, as you saw, goes directly up from here into the attic. Okay, and then they left a ton of these. Of course, these are the sensors, magnetic sensors. And then this is the loud guy right there. It looks small, it looks innocent. It's a plain white box. That thing is loud and it scares the shit out of the cat, I promise you. Okay, all in all, there's the list. I have 13 windows, 3 doors, a motion sensor, a very loud siren, 2 smoke detectors. In the video, you saw one near the basement, near the HVAC, right where it needs to be. I have another one that's in the ceiling, kind of the center of the house. Another good place for an HVAC or for a smoke detector. And then, of course, the camera we talked about. So this is me getting the control panel hooked up here. And again, I was very frustrated here with some power things, and I'm going to go into those in a little more detail here. But you can see the kind of the makeshift way I had to get power to this Raspberry Pi. Okay, let's talk magnetic sensors. So there's a little bit better view on the left of what that looks like. So on the door here, you can see this little circle. That's just a magnet. All you do, drill a little circle, a little hole in your door, and then stick it's a little magnet that they stick inside there. So that magnet actually comes it doesn't come actually in contact, but it comes close enough to the sensor, which is right here. That's the other side of the door. Behind here, again, they drill a little hole. There's 2 wires that come back there. When this magnet gets close, the switch is in here. The switch, when they get close, is closed. So those wires are connected. When the door opens up, the magnet pulls away. The magnet causes the switch to open. The wires are disconnected. Simple on and off. Similarly here with all the windows, the magnet is this piece here. That's why it doesn't need to have any wires or anything. When a magnet is near the sensor, it's closed. When you raise it, the switch in here opens up, and then of course these wires are open, so they become low. Hopefully that makes sense. All right, so where did I start? Well, I had to reverse engineer this mess of cables. So by design, ADT wants you to pay a monthly fee. I think it was like $50 for my case. And so looking through these wires, they all had little tiny numbers. I had to have like a magnifying glass just to see the little number that was on each one of those wires. And of course, they don't tell me like when you see number 1, it actually goes to this window, and number 2 goes to that door. None of that. So I had to bring my trusty old multimeter. You can kind of see it right there on the edge. Find a wire and then connect it out, and then look for shorts. So if you're not familiar with multimeters, you can set it to there's a diode tester mode, or you can put it on just ohms, right? Connect it up, positive and negative side of the wire. Most of them are 2 wires. And then just walk around and look like an idiot opening every single window you have in your house. Do this until it goes open, right? Because by default it's closed, so you've got a short circuit. Wait until it goes open, bingo. You found the wire that goes to that window. So that was probably the most tedious part of the project, was figuring out all this mess of wires, labeling. So you see my little labels here. I get this all stored in an Excel spreadsheet so that I know 16 actually goes to this window so I don't know how all the wires go together. So fun project and aggravating also, because I found in doing this, my wire down here, my sensor down here was broke. So this one, it's hard to see there, but it says ADT. I've since ripped this off and put on a new one that I bought on Amazon. The sensor was bad. All right, let's get into some circuit diagrams here. So these are all syste circuit diagrams, nothing really complicated here. You can see down here is the Raspberry Pi. I've had the 4 Raspberry Pi 4 with the 4 gigabytes. They now, I think, have an 8 gigabyte, which is better than mine. Now I have to go out and buy new ones apparently. I don't need the extra 4 gig. But the pinout on the Raspberry Pis have been consistent. I don't think they've changed much throughout the years. You can see here with the circuits, the GPIO, so general purpose input output pin. And you get a bunch. So you can see here 21, 20, there's quite a bit. Some of these pins are dual purpose. So for instance, up here, GPIO 14 and 15, I believe this is the UART serial port. So you can either use it as general purpose GPIO input output, or use the serial functionality of this. So again, this is setting down in my basement. I didn't need anything but GPIO pins. I didn't need any serial or any special pins there. So I used pretty much all of these pins to wire up all my windows. Okay, so how are they working? Well, so here's the magnetic sensors, and I mentioned their switch. That's all they are. By default, when they're close together, the switch is closed. So there's a couple ways you can wire this up with the Raspberry Pi. What worked for me was using what they call a pull-down circuit. Basically, I connected 3.3 volts, which is the output of the Raspberry Pi, not the GPIO pin. It's one of the outputs. You feed it 5 volts and it can make 3.3 volts. So I fed 3.3 volts down that line to the positive side, one side of the wire. The other end, I connected to one of the GPIO pins. So those numbers you saw on the little stickers, so each one of those mapped to one of these pins. So like, number 23 was one of my windows, and I connected it to that side, the other wire of that sensor. Internally, there's a pull down resistor so that I don't get 3.3 volts going directly to ground. A lot of people, if you go online and see, they put another resistor out here in series as kind of a safety safeguard. I didn't see a need to do that. But you can read all about why that's important, why you may want to do that. The internal resistor worked good enough for me. So the idea is it's 3.3 volts high until these get further apart, the window opens, this switch opens, now this pin reads low. So now I can react to it being high or low, true or false, in my C# code. See, pretty sissy. Okay, let's get a little more complicated. Not really. This is the motion sensor. Works pretty much identical to the magnetic sensors in that it does have a pull-down circuit, 3.3 volts. So this portion right here is identical. What I found with this, and I kind of knew, is that it needs powered, right? So it has a little LED. You saw in the video, it turns blue. It requires powering up with 12 volts. So when I found out, I figured out all my doors and windows and had just a few cables left in there. I found one that had 4 wires. Here's your 4 wires. 2 for the sensing part of it, and then 2 to give it just 12 volts to power it up. Now we get a little more complex. So we've got doors and windows taken care of. We got the motion sensor taken care of. The siren was the next thing. I needed to be able to power the siren. Took the siren off the wall. You guys saw it there, that little white box, and realized it only had 2 wires going to it. And also reading through the back of the box, realized that it takes 12 volts to power it up. So that's it. So I, of course, being naive, applied 12 volts to it and about blew my eardrums out. So basically how it works is you give it 12 volts, it makes loud noises. You give it no volts, it makes no loud noises. Simple as that. So I'm like, okay, that's interesting. Well, let's go to look at the Raspberry Pi. The GPIO pins operate off 3.3 volts. So I can give it 3.3 volts, but there's 2 reasons that's not gonna work. One, obviously I just said it takes 12 volts. Heat, it takes 12, not 3.3. Not gonna work. The other big thing, even if this did take 3.3 volts, the GPIO pins on the Raspberry Pi are not meant to power things. Don't do this. Again, it's another one of those things when you get into this and start building this out, you do some research. The Raspberry Pi, you'll either harm your Raspberry Pi or in most cases it has self-protection. It'll just shut off. It'll power off. You can't draw much current from these GPIO pins. They're not meant to power things, only to process digital logic. So crap. Well, I need to be able to control it with 3.3 volts GPIO pin, but it takes 12. There comes a relay chip. So you've probably heard the term relay, maybe familiar with it, but maybe not exactly what it does. There's the exact chip I used, bought them on Amazon. They were pretty cheap. This blue piece right here is the actual opto isolator, optocoupler. Some people call it an optocoupler. How it works is there's a little light emitting diode in there. You turn it on or turn it off. It makes light and then switches the transistor here, which then basically acts as a switch to turn 12 volts on or off. So I can use my 3.3 volts to turn this thing on, which then either opens or closes the 12 volts feeding this. So exactly what I needed. So how's it all wired up? Well, this chip has some other things on here and LED, so it needs its own power. So I gave it 5 volts. 5 volts is the same thing that the Raspberry Pi needs to be powered. So I already had an adapter there. So fed it in 5 volts, of course, gave it a ground, and then connected it to one of my GPIO pins in output mode, not input mode. I need to be able to output a high or low to this pin. Over here, there's 2 operations, normally open, NO, or normally closed. And depending on if you want the device to normally have power or not have power, depending on how it works. In my case, I don't want that thing to ever have power unless someone's breaking into my house just because it's so damn loud. So it's normally open. And then when I switch it on, it closes, provides 12 volts there. So it's kind of how it works, but that's not the most complicated piece. Last sissy diagram. This one is a little more complex here. I almost gave up, but stick to it. When you're working through a project like this, you can find a way to make things work. I have smoke detectors. And of course, I took them off, looked how they were wired up. They only had 2 wires going to them. And those 2 wires were for 12 volts to power them. So cool. I can give them 12 volts. The light comes on. I can press a little button and it goes off. How do I know when it goes off? How did ADT know? Well, done a lot of research, Googling the serial number in the back. Come to find out there's a separate board that these connect to, and then that board goes into the ADT system and is wired up there. So I found the board on eBay. It was like $120 used. I could figure out how to make this board work, pay a lot of money for it, and got a little frustrated. But then I got to thinking, me with my reverse engineering mind, I'm like, okay, well, what happens here? So I took my multimeter, good old trusty multimeter, and I connected it up in series to measure amps, so the current going through it. And what I found is when I connect these things two up to 12 volts and I measure the current flowing through both devices with nothing happening, just it there being idle, I was getting 8 milliamps. And I went and then pressed one of the buttons to make it go off. Well, that speaker draws current, right? It needs power to be able to power that speaker. So what I found is it goes from 8 milliamps to about 50, 60 milliamps for one of them. And then of course, with both of them are going off, it's a couple hundred. So bingo, that's it. I needed a way to measure the current going across those. And when I see it go from 8 to something way greater than 8, that thing's going off. So did some research and found here's an ADC chip, so analog to digital circuit chip that I use to measure that. So out of the box, the Raspberry Pi only talks digital. It doesn't do anything analog. This is an analog signal, milliamps is what I want to measure here. So I needed a chip that could take that analog signal and turn it into something digital I can read with the Raspberry Pi. So there's the chip I bought. The form factor is weird. That's the only I could find at Micro Center. It was $7, so $7 versus $120. Yeah, that seems like a way better deal. But they make one that's, I think, a better form factor for the Pi, but for what I needed, this was okay. I think it's called Feather something or other. It's another circuit board. Anyhow, the chip required to be powered up, so you can see it's got 5 volts going to it with ground. It communicates to the Pi with an I2C interface. So I2C interface is a hardware interface, very common, been around forever. So you've got 2 wires here, SDA, SCL, plug them into each other, and it basically acts as a bus that you can communicate. The wiring over here, so again, these need 12 volts. So I needed to ground one side of it and give it 12 volts. But this thing needs to measure the current going across that. So it has a V plus and V minus. And without getting into a lot of details, you know, if you have something drawing a lot of current here, it's going to break the chip. So it uses what they call a shunt resistor. You can see right here, this little shunt resistor. You can read all about it. It's really cool how it works. So it doesn't actually measure the load. It measures this shunt resistor going across there. Needless to say, I was able to get exactly what I needed. With this, I can get the volts, the shunt volts, which I don't really care too much about. Milliamps, or the amps going across here, is what I really wanted. Okay, that's it on my desk, working through it. You can see all the mess of wires here. If you do a project like this, you're going to have a lot of these little test leads to be able to test it up. Test before you get it mounted on the wall or in the case. Okay, I know you're judging here. It's kind of a mess. It's better. It's getting better. But hey, when you close it, just a gray box, right? You never know that it's a mess. But yeah, it's part 2 is to clean it up a little bit more. Works for me though. Okay, let's talk control panel. So this control panel, this case that I bought here was rather expensive. Doing some research, I bought the standard Adafruit 7-inch touchscreen LCD that marries up to the Raspberry Pi. Works great. It's relatively cheap too for touchscreens. I think it was like $50, $60, which is not bad at all, and it hooks right into it. So I found this case that looks rather nice on the wall, I think. Connected up. You saw on the back of it, it takes a 4-gang box to get it all wired up. But again, rather expensive, but kind of worth the project. I was all in at that point. And here's my power woes. So sad. Okay, why the heck did you do this, Heath? Why did you need to do this? Well, this is where the control panel for the ADT system was, right? So I needed to drill it out a little bit bigger and put this 4-gang box in there. But you can see there's 4 wires here. So they were using 4 wires for I'm not sure what. But these wires went all the way down came out, and then went all the way back to my gray box that you saw out there. So my plan was, I need 5 volts to power this, so I'll just take the red wire and the black wire, give it 5 volts, and mount the thing on the wall, and we'd be good. That's not the case. Thing wouldn't even power up. It's too far away. I've got like 20 feet of beam from this point back to where you saw in the video. Plus, it's got to go 10 feet up. No way in hell that was working. So I thought, okay, maybe I just need bigger gauge wires. I twisted these things together so I could get 2 wires to draw the current, enough to draw the current. It powered up. Then I got they call it the lightning bolt of death that comes up on the LCD, meaning yeah, I'm powered up, but I could shut down at any point in time. Don't work me hard. It was kind of there, like making fun of you. So then I bit the bullet, moved the power supply closer over here. I still required both wires to be twisted together to get a big enough gauge of wire to carry the current. This worked. This goes straight up. It's about 10-foot run. So the Raspberry Pi 4 is pretty power hungry compared to other ones. Okay, Heath, so why Raspberry Pi? I mean, there's other boards out here you could use. For me, C# and Ubuntu. I'm not a big Linux guy. Being a C# Microsoft developer, I do a lot of Windows things, right? But used quite a bit of Ubuntu. And when C# first came out on Linux, I fired up an Ubuntu VM and played with it, loved it. So that's the reason. I know Ubuntu works on Raspberry Pi, and I know it can do C#. So, and frankly, there's just a lot of documentation out there for Raspberry Pi. All right, let's talk about some software things. If you guys have any hardware questions, we'll probably have some time at the end here. Just drop them in the chat there, and as they pop up, I can see them and maybe answer them. All right, so let's talk about the software here. So first and foremost, I am an architect, right? Therefore, everything needs to be hexagonal or onion, or right. I mean, that's what we need to do. So it is onion architecture, but a very lightweight onion architecture. I don't want to go crazy. It's my own personal project at home, not a big enterprise project for one of my clients. So let's call it small onion. Starting at the bottom here and working our way up, we've got the Raspberry Pi hardware drivers, right? I didn't write any of those, obviously. It came pre-installed with Ubuntu. Ubuntu provides a version that's a server version built strictly for the Raspberry Pi. Go download it. They have the loader, I think that you can use to load up your SD card with it. Really easy to get through. It doesn't come with a UI, so if you need a user interface on the upstairs one in the control panel, I need a user interface. I need a browser. I need to run that site in a browser. Downstairs in the basement, I didn't, right? It's all completely disconnected. I SSH into it, so I didn't need a UI. So you can install a UI if you choose to do so. .NET Core 3.1 is installed on that. Did a manual install. Tried to do apt-get, which is what Microsoft recommends. Couldn't get it to work for whatever reason, and the manual install was just as easy. Copy it down, put it in a location, you're good to go. The key with it is these right here. And I think what you're going to find when I get to the code portion of this made all the difference. There's 2 NuGet packages, system to device.gpio, and then IoT to device.bindings. These make C# working with hardware freaking easy and awesome and fun. Highly recommend. There's tons of, especially in this NuGet package here, there's a lot of open source people, writing drivers and writing C# wrappers for you to be able to integrate with hardware out there. So it's a real lively group and a lot going on in this space on GitHub. Of course, I need SignalR, some hosting. So SIMD is allowing me to run this as essentially it's like a Windows service on Linux. And then of course, the entry point is my DLL for my application. Word of advice, and I know I told you the siren's loud, but I'll tell you again, GPIO pen state, that's hardware, right, outlives your code. I wrote a bug here in this code, and I was trying to test to see how this, to make sure my siren would work, the relay, I can turn on the relay on and off. Well, there was a bug in there, and the stupid thing crashed. it did not turn off the siren. So no matter what I did, I had to run downstairs and yank the 12-volt connection to turn the thing off because the Raspberry Pi said, I don't care, it's your app crashed, I'm still keeping that GPIO pin high. So word of advice. Okay, control panel stack, very similar. The bottom portions here are identical because it is the same. It's also Raspberry Pi, Ubuntu, .NET Core 3. Things change a little bit up here. So I've got Entity Framework Core, and I'm using the plugin for SQLite. I am using code first migration, so I build out my entities at startup time. It creates the database if it doesn't exist, and then runs all the schema migrations to create the tables as needed. It is ASP.NET Core, so I've got a web server running, and on top of that, I've got SPA services. So if you've not used that before, it's been out for quite some time now. That allows me to host my Vue.js app within .NET Core. So I can serve it up and have basically all the routing and all that done in Vue.js and not in my MVC controllers. And then of course, SignalR, I've got SignalR client, so I can connect to my cloud, and then the SignalR itself to be able to create the hub for the server monitor to connect to. Okay, don't be this guy. What's that, you say? What is on there? What is that little thing? Oh yeah, I've got a software update for you. Do you wish to install, sir? Why yes, I'm walking by, I'm gonna go out, I've got a little while. Let's click that little install now button and see what happens. Yeah, and then when you come back from whatever trip you're on, your touchscreen doesn't work. Be careful with this. This is a lot of gotchas here. I didn't think this would be an issue at all, but just installing updates somehow caused the touchscreen driver in Ubuntu to die. On a normal PC, you could probably revert those, or I Googled and tried to figure it out. I had to completely take this off the wall, disassemble everything, take the SD card out of the thing, take it back upstairs, re-image, reinstall Ubuntu, reinstall all the drivers. Oh, what a pain. So yeah, that thing's evil. Stay away from it. Okay, cloud dashboard. Not much super exciting here. It's probably what you guys are using at your client sites today. Again, any framework core, using code first with SQL Server, ASP.NET. There's authentication, right? So I'm using the identity services baked into ASP.NET with the username and password. All I've done is just bolted on the JWT package so that I can handle JWT tokens from my Vue.js app and from the control panel. And of course, it wouldn't be Azure if I didn't show you my Azure dashboard. Not much going on here. It's not that exciting. Jamesport's where I live. Got an app service, SQL Server, and then I have an S1 plan. I've got a few other things running on. So, and of course, we have to talk back to the cloud thing about unicorns turning datas into analytics. With this whole thing, I'm capturing, like, every single time a door opens and closes, I'm capturing that as an event. Why? I don't know. Maybe I can track some time. Maybe I can crunch it through some like machine learning algorithm in the cloud that Azure provides, and somehow determine at a later point in time, like, I predict that your window is going to open at this time on this day, and it's kind of cool. I don't know. Who knows? But I am capturing basically any status change whatsoever in the SQL Server database. Okay, I did promise you a demo like 20 minutes ago. So let's jump into it. I've got about 10 minutes here, which is, I think, plenty of time to get through this. Let's do it. Okay, I'm going to minimize comments, so you won't be able to. I won't be able to see your comments, but I promise you we'll have time here at the end to go through everything. Okay, I've got one thing I want to show you. I don't have time to go through all of the code here, which is unfortunate, but I'm happy to share ideas with your thoughts with you if you have questions after. One thing I did want to show is how stinking easy it is to connect to this hardware. So here's my security monitor service. This is the only code I use to directly interact with the hardware. Lots of codes up here. I promise you, there's no shenanigans going on. Let's scroll through here. A lot of this is boilerplate, 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 boilerplate. It's only 134 lines long. Can you believe that? I did all that hardware manipulation in C# with only 134 lines. Let's walk you through it. So here's where I need to map. I mentioned the GPIO pin, right? So here's where I say, okay, on the Raspberry Pi, GPIO pin 13 belongs to this. I gotta have that mapping, so I store that mapping up here. It doesn't change. I've defined it one time, and it's up here. So I've got an initialize. So when this thing my application first boots up, it calls initialize. It creates a new GPI controller. Again, this is all part of the NuGet package. I didn't write this code. And I go through all those pins and I say open pin into input pull up mode or pull down mode. That was that circuit I showed you. So with pull down mode, it enables that internal resistor and all that goodness. And I pass it the pin number, which is basically going through this list here. And then similarly with my alarm here, or my siren, I put in output mode because I need to write to this thing. But I also want to set it to low. So when this thing first boots up, I want to make sure this thing's off, and not on. Okay. This is the code. I mentioned that open source NuGet package. This is it. So this is provided through there. So this is the code that I wrote to measure current. It was all provided, a lot of good documentation on how to wire it up. It seems complex, but it's really not. Basically, this is from their website. And then get sensor status is called every 2 seconds. So it's called, and basically I run through here. So some boilerplate code going on here, but really, how am I getting the status? Right here. So I say GPIO controller read. There's the pin number, right? And the pin number is what I've assigned above. Get a value. Okay, now I have the value. Well, if I'm low, then I know I'm either open or detecting motion. And if I'm high, then I'm closed or no motion. Simple as that. I couldn't get easier than that. Simple Boolean, true, false. Check your statuses, shuttle it up. Same with the siren here. I wanted also, even though I set the siren as a write pin, right? It's an output pin. I read from it too as well. I want this to be the de facto source of truth of if that siren is on or off at the hardware level. I didn't want some cache somewhere in some layer cause the issue. I wanted the source of truth to be that server, that sensor monitor, which is down here. So that's why I read from it, even though it's an output pin. I can do that. And then the smoke detector status. Again, there was some complicated code up here. Most of this I copied from their examples that they had. Reading it couldn't have been easier than this. So I say read current, scale it, because by default it's in microamps. I need milliamps, so scale it by 1,000. Okay, now I've got milliamps. Is it greater than 30? I know for a fact that 8 milliamps is nothing. If it goes above 30 for any reason, that means one or more of those sensors are going off, then the siren's on. We've got problems, else it's off. And then I'll do some other things here, which is not that important. All right. Last thing I want to show here in code, and then we'll jump into the applications themselves. So with this, I didn't want to actually run around. I thought it'd be hard to be here in front of a camera in front of you guys, but also run around and open windows. So this is simulated. This server monitor that I have here just reads this file, so I can simulate opening and closing things. And I have not that. I have 2 things open here. There is my control panel, and of course the phone application. True story. I've simulated the hardware, but my cameras, all I'm doing with the cameras that I've got installed, they don't provide an API to do much more than just pinging. So I send a GET request, I get back a response, and if I get a response back, then I know I'm good. This damn front garage has been a problem. It's a little bit further away from the Wi-Fi, and I may end up sending this back to, it still works, ironically, using the app that it comes with on my Android device. But pinging it with code for some reason, it's not happy. So that's why you see red there. One thing I didn't really cover, this down here is the signal R connection. So I put a little indicator on there. When the connection is currently connected and open, I show green, else red. That's important because if it shows red, and this is red up here, if I'm just happen to be walking out the door, I'm not going to be down there watching the hardware every minute of the day to know that that's actually working. So this will let me know if the connection's bad or the hardware, something's wrong with it. So, and then similarly over here, I've got a little lock. I can choose to log out if I want to, but I think by default I keep the token in there for way too long than I should be, for like a year, but I don't want to log in every time. Okay, let's show a demo here. I've got about 5 minutes, so I'm going to go through it pretty quick here. So I can go, let's go out the front door. So I can come here and say front door, open, save that, minimize, and you can see right there, front door is now opened pretty fast. That's all that signal are. Similarly, I can go over here, go to current status. I've got a door open, 1, and scroll down. There's the front door, it's open. So also, you can see this is kind of the audit history. So I can see, it opened at 3:40. That's 3:40. They can see kind of the history of when it was open and closed. It's all coming from the SQL Server database. Also, on here, I can arm the system. So if I go back here, and you can see how fast that is. Now, granted, it's running on my machine, so of course it better be fast. But as you saw from the video, even going all the way to Microsoft's cloud and back, it was pretty stinking fast. So that's good. So system is now armed, and you see it's armed and detecting an alarm status because the door is still open. But over here, there's this little section for alert notifications. There's nothing there. Reason being, this I haven't fully wired up like actual push notifications yet. That's on my list of things to do. Didn't quite get to it before the talk here, but this will push a notification to this area here. But I didn't want, if you go and you arm the system, it's going to take 30 seconds, 10 seconds to get out the door, close it. You might be carrying things. I don't want to get all kinds of alerts and alarms on my phone that some bad things are going on when they're really not. So, so I think I set it for like 3 or 4 minutes, but for this talk, it's less. You'll eventually see something pop up there. But imagine my luck. I get out the door and the fire alarm goes, or the smoke detectors are going off. So let's set those on. Oops. Casing matters. And you can see, boom, it's going on. I immediately want to know, right? If my smoke detector is going off, I immediately want to know, immediately want to push notification. Tell me as soon as you possibly can. So you see this system is armed and detected activity. It did finally come up. Just like I think a minute or 2 versus like 3 or 4 is what I normally have it programmed at. Okay. Lastly, I talked about it, but I didn't show you. I tucked it away down here because it's loud. I don't want you to do it very often. You have to click many times. You click here. Okay. Then you click here. Then you really have to be certain you want this alarm sign to go on. And of course it's on. And couldn't really tell there. I guess it was too fast there. There was a slight delay. So when you click this, I go through if you remember all the layers of Signal R, this goes down to the hardware, actually turns it on, confirms that it is in fact turned on, and then comes back up through. So there is a delay here. I can probably, okay, you saw the delay there. That's on purpose. I want that to be the owner of that, and I want that to eventually come back up through to prove that it did in fact get on. So last thing here, we have just 2 minutes, is with these I can dismiss. So actually, if I disarm it, I can dismiss these and get these off. But that is pretty much it. So in closing, so for the project itself, you're going to learn a lot. So if you take this on, you're going to learn hardware, you're going to learn software, you're going to learn all the pains, be on the cutting edge sometimes. You're going to fail a lot. I promise you that. I did, but it's kind of fun. And like I said, don't give up, right? Because I almost gave up on those fire alarms, but didn't. .NET and Linux on Raspberry Pi, it's ready for prime time. I remember when this first came out, what, 2, 3, 4 years ago, maybe even longer. It was flaky, didn't quite work, didn't support all the libraries that I needed. It's ready, so it is there and ready. And then I mentioned this before, but Signal R Core, you don't need hardware, you don't need Linux. You should be using this today in your projects at your clients and workspaces. So hopefully you enjoyed this. If you haven't checked, a quick plug to my company, right? So, I'm here, I'm, getting paid to, be here delivering a conference. So great company to work for. We do have a presence down in Louisville. We have an office down there. Come check us out. There's our website. Of course, big into the cloud thing. So that's all I got. I think I'm out of time. You can see if there's any questions here. Well, I could if I could bring up my. Oh, there we go. Okay, guys. Hopefully you enjoyed it. Yeah, take it on. It's a lot, but it's fun. It was definitely rewarding, Kendall. I tried using Untapped. I really did. I wanted to use it, but it became a burden. Like I get to a bar, I'm there with some buds. I just want to like drink beer and not to log in and do that. So I have an Excel spreadsheet that I've tracked just pumpkin beers. I'm going to break 100 this year. I think I'm at like 98. Um, a glass detector. So the question was any other sensors, and yeah, I do wish. So downstairs in my, I call it the Buckeye room because I live in Columbus, Ohio, but it's my pool table room. Inside there's a window that's barely above ground. It's kind of a half underground, half above ground. It's a 5-level split house. I want to put a glass detector there to detect if someone would kick in that window. So that's again another future project. I would, if I were to do this and my house was not wired up ADT, yeah, I would go on wireless for sure. Because I just lucked out and it was already pre-wired, and I wanted to take on this project. I didn't even have to need to do that. And also where I'd put the glass detector, I have an extra wire going to my box. It's setting right where I want it. So I wouldn't even need a wireless for that. Okay, guys, I'm going to drop out of here. So hope you enjoyed it and have a great rest of your day and a good weekend.